Greetings from Team Piping Mantra and welcome to our session on Module 7 where we will discuss about pipe fabrication and installation. So without any further delay, let's get started. Let's start with what is pipe fabrication. Pipe fabrication is the process of cutting, beveling, and welding pipe components like pipes, tees, elbows, flanges, reducers, etc. Piping fabrication is a highly critical activity requiring high precision and involving hundreds of components and thousands of steps. Pipe fabrication projects within construction projects must be adequately planned, scheduled, and executed according to design requirements. You should ensure maximum quality of work in a pipe fabrication facility to maintain the system integrity and minimize accidents. Now let's talk about types of piping fabrication. Pipe fabrication work is divided into two groups, shop pipe fabrication and field pipe fabrication. Several factors will determine whether pipe material will be fabricated in a shop, in a field, or if both methods will be utilized. Both shop and field pipe fabrication will be used more often than not, like the type and size of the project, piping material, post-fabrication surface treatment, time requirement, availability, environmental conditions, and skilled personnel availability, accessibility and safety concerns. If the project is for existing or new piping systems, all help determine where projects will take place. Small bore pipes, threaded and socket welded pipes are field fabricated. Butt welded pipes, pipe bending, and modular items are typically shop fabricated. With the shop pipe fabrication process, pipe fittings and components are assembled with a quality weld to spool assemblies at the pipe fabrication shop. The spools are labeled with an identifier and transported to the construction site to be installed. All the assemblies are completed at the construction site with field pipe fabrication. The pipe fabrication process is very detailed from beginning to end, no matter what size of the project it is. Engineering information like engineering drawings, inspection, testing requirements, and applicable codes and standards related to the project are contained in a single document. This document is called the Pipe Fabrication Specification. Every pipe and its fittings should be manufactured and assembled according to the spool drawings in the Pipe Fabrication Specification. Pipe fabricators also need to consider the size of the assembly for transportation purposes. It's often helpful to have sub-assemblies to separate large projects into more manageable elements when transporting the items between the shop and the project site. When pipe fabrication specifications are completed, the pipe fabrication process looks like this. First is marking and cutting. As per the design drawing requirement, marking shall be done and the same shall be verified by the concerned supervisor prior to cutting. Pipe cutting is normally done as follows. Carbon steel pipes by gas cutting and grinding, alloy steel pipes by grinding or flammable cutting, stainless steel pipes by grinding or plasma cutting. Next is tagging. Pipe materials are tagged with paint or a stamp to ensure pipe heat numbers are displayed before cutting. Next is end preparation. It is when beveling and fit-ups are completed. Next is welding. Pipe welding planning ensures that pipes are positioned correctly during the process of welding piping. Next is pipe and fitting welding. Piping and fittings are supported for a fit-up inspection. Next is details marking. Various details like pipeline number, component heat number, joint number, fit-up inspection signature, welder number, visual inspection signature, and welding date are marked near the joint using a metal paint marker. The pipe spool number is marked with a paint marker and an aluminium tag is tied to the spool. Next is heat treatment. Preheating and post-weld heat treatment may be completed. Inspection. Non-destructive testing ensures that all fabrication process steps are complete and meet or surpass the project requirements and codes. If the piping that passes is released for painting or construction, if it doesn't pass, it must be repaired and re-inspected. Piping that is to be painted will be inspected again before being released for construction. Documentation. After painting, field inspection is executed for QC or quality control and the same is recorded in the prescribed format. After the painting inspection, the spool is released for erection. Fabrication of stainless steel pipes. Stainless steel piping fabrication is normally done in the shop with an isolated area from carbon steel and alloy steel. The equipment and tools which are used for carbon steel fabrication shall not be used for stainless steel. Tools for stainless steel must be differentiated clearly by marking for stainless steel only. For stainless steel materials, stainless steel tools will be used for grinding, brushing, and clamping, etc. Protection. For the protection and temporary storage till the erection, all flanged raised faces of completed pipe spools are fitted with plywood blinds and spool ends shall be fitted with proper caps. Now let's have a look at tools and equipments used for pipe fabrication. Pipe fabricators use various specialized equipments to complete jobs safely and efficiently. Pipe fabrication equipment designed to handle medium to large scale projects is only used in the workshop. It needs appropriate space, weather protection, reliable security, and complete quality control capabilities. Many pipe fabrication tasks for smaller projects or those with logistic limitations can be completed in the field. No matter where the work is done, several essential tools allow pipe fabricators to create the complex precision piping systems that surround us. The widely used equipment is listed below. Chain clamps or C-clamps, pipe fit-up tools, pipe purging equipment, pipe cutting and beveling equipment, torque, wrench, adjustable wrench, combination wrench, hammer wrench, flange alignment tool and pins, pipe jacks, adjustable pipe rollers, welding machine, pipe rigging and transport equipment, center punch, compass or contour marker, pipe threader, forklift, grinder, wraparound tapes, hydraulic crane or tower crane, and pipe bending machines, etc. Now, let's discuss the last topic of this session, that is modularization concept. Modular construction involves prefabricating equipment and systems into modules off-site in a controlled manufacturing facility. In recent years, the use of modular construction in the oil and gas industry has become increasingly popular because it provides a number of advantages over traditional stick-built methods of facility development. There are different approaches of modularization like pipe rack module design including piping, structural steel, platforms, valves, cable trays, and instrumentation. Equipment modularization including equipment design, module layout, and optimization and operational review. Modularization studies including schedule, cost, complexity, facility location, new installation versus brownfield, facility congestion and accessibility, and construction strategies. Transportation and logistics studies including route selection, shipping dimensions, and weights. Modularization offers many advantages over stick building methods such as lowering the overall project cost by completing work in a shop environment, taking advantage of shop versus field labor rates and working in a controlled environment like for project planned on Kazakhstan where normal temperature during winter is minus 40 degrees Celsius, modules can be built over India or China so that owner can take advantage of cheap labor as well as avoid harsh environment conditions of Kazakhstan, which is not feasible for such a big fabrication activity. Lowering the cost of coating, instrumentation, heat tracing, insulation, and hydro testing. Increasing fabrication quality and productivity, and optimizing the inspection process. Fabrication, assembly, and testing time is reduced dramatically, simplifying on-site assembly, resulting in less installation time and less field crews, allowing an increased number of simultaneous on-site project activities, which reduces the overall project duration, reducing the risk of unpredictable on-site weather conditions, which causes weather delays, resulting in a smaller on-site footprint which saves project cost. minimizing time for commissioning and startup as well as turnaround time for brownfield expansions. So that is it for today. Next time we'll start a new session with some new and exciting content. So stay tuned for that. Till then, bye bye. Take care. See you next time.